Okay, in the last video we worked through all the gory details of the reasoning. In this video we're going to see a faster, easier method of solving a polynomial inequality. First, we pretend it was an equals sign and we find out where each factor is going to equal 0. And at this point in the course you might be able to do this in your head. We set x minus 4 equals 0, so x equals 4. Or 2x plus 3 equals 0, so x equals negative 3/2. Or x plus 5 equals 0, so x equals negative 5. Or finally, 3 minus x equals 0. This one's easier to solve intuitively than using the algebra, right? This is true if x equals 3. So those are our cutoff points. Those are where the product is going to equal 0. We mark those on the number line. And just like when we were using number lines for compound inequalities, it doesn't matter if those numbers are spaced correctly. In fact, we're not going to space them correctly. But it does matter that they come in the correct order. So negative 5 is the least, that comes furthest to the left. And then negative 3/2. And then 3. And then 4. So when x is 4, this first factor is 0. When x is 3, this last factor is 0. When x is negative 3/2, this factor is 0. And when x is 5, this factor is 0. Now, for the rest of this, we're not going to be concerned with what actual number we have, just with whether it's positive or negative. So x minus 4 is going to be negative all the time when x is smaller than 4, right? If we take something less than 4 and subtract 4 from it, we get something negative. So I'm thinking of each space. And I'm also thinking of each tick mark as I'm going through and marking these signs. If x is more than 4, then x minus 4 will be a positive number. Okay, so this one's a little bit harder to think of. We might need to try a number. 2x plus 3, well, 2 times negative 5 plus 3 is negative 7. That's negative. 2x plus 3 is negative to the left of negative 3/2. And then it's positive to the right of negative 3/2. X plus 5 is going to be positive as long as x is bigger than negative 5. Right, x plus 5 is positive for big numbers. And then it's negative for small numbers. 3 minus x is weird. 3 minus x is negative for big numbers, right? 3 minus 10, for example. If we have a number bigger than 10, if we have a number bigger than 3, then 3 minus it is negative. But if we have a number smaller than 3, then 3 minus it is positive. Notice, I didn't really do any algebra to find those out. I could have done algebra similar to what I did in the last video. For example, x minus 4 is greater than 0 when x is greater than 4. So I know the positive part is where x is greater than 4. But I don't need to do that algebra. I can just think about what I know about the structure of numbers. The way to get x minus 4 to be positive is to have x be a number bigger than 4. Okay, now how do we use this? At each of these cutoff points, the product is going to be 0. There's a 0 in each of these columns. In each of these cutoff points, the product is going to be 0. And then here, we have a negative times a negative times a negative times a positive, which is going to work out to be negative. Here, we have a negative times a negative times a positive times a positive, which is going to work out to be positive. Here we have 1 negative and 3 positives. That's negative. Here we have 2 negatives and 2 positives. That's positive. And here we have 3 positives and 1 negative. That's negative. Right, we know this about multiplying signed numbers. If we have an even number of negatives, then the product is positive. If we have an odd number of negatives, then the product is negative. And this even or odd thing is probably the easiest way to do it. Now we look back at our original inequality, and we see that our original inequality wants to know when the product is less than 0. We're looking for the set where the polynomial is less than 0, so where the product is negative. That means that we're looking not at -5, but to the numbers left of -5. Not at -3/2 and not at 3, but at the numbers in between. Not at 4, but at the numbers greater than 4. That's why we've marked our product as negative. So that's going to be where x is less than -5, or x is between -3/2 and 3, or x is greater than 4. That's our solution set and set builder notation. In interval notation, that's -∞ up to -5, union -3/2 up to 3, union 4 up to infinity. You can use whichever notation you prefer. For this one, I think the interval notation is probably easier.